Good afternoon, everybody. We are going to discuss on analytical chemistry uh, about identification of ion. The rationale of this test: when people are consuming water, they can have the hazard, but they cannot know the cause of the problem among ions. Depending on where the pollutant, where water is passing through, people in charge of water and sanitation are obliged to look for reagent, and the reagent will identify the harmful ion and to look for the techniques or strategies of removing those ions. In this case, we are going to see whether you have water containing either magnesium ion, lead ion, and zinc ion, and you want to identify them. As we have seen in organic chemistry, that if you want to distinguish between two reagents or three reagents, you select two or three compound, you select a reagent which is giving the positive observations or observable change, and another which is giving the negative observation or no observable change, or they can give different observations. First of all, what we call observations are something which is reflecting to our sense organs. For example, the color of the precipitate, the smell, the sound, and so on. For example, oxygen is characterized by igniting the glowing splint. Hydrogen is characterized by pop sound. Carbon dioxide is characterized by effervescence of the gas which is turning lime water milky, and the gas which is colorless. And ammonia is characterized by a pungent smell. It means that also all observations are characterized by the effect on our sense organs. But on this point, first of all, we are going to see the reagent. First of all, the reagent should be observed for some ions, but others are not giving the observable change. First of all, magnesium is in group 2, lead is in group 4, and zinc is in the side of the transition element, even though it is not generally considered as a transition metal, because there are some properties of transition metals which are not found on zinc, such as complete d orbital, which is found d subshell orbitals, which are found on zinc. But zinc has some properties which we can find, and the position of zinc is the nearest of the transition element. Lead is above, below nanometer, means that in lead there are some properties of amphoteric, the same as zinc, but for magnesium is in group 2. But both three are forming hydroxide, which are white precipitate. It means that first of all, we are going to use sodium hydroxide solution. If we use SQ, means that it is in water, because in Latin, water is called aqua. Then aqueous solution is when the solvent used is water. Then, first of all, if we start by zinc 2 ion, we add sodium hydroxide, but this is aqueous and is colorless, and sodium hydroxide aqueous and so colorless. When you are testing, you start by the solution in the good way. You start by solutions which are colorless. Then you want it to either a precipitate or a colored solution. In this case, you find that the product will be, as the equation balanced, will be zinc hydroxide solid including two sodium uh, ion. It means that if I have zinc chloride, for example, I will have two sodium chloride. This is a white precipitate. This white precipitate, on another side, we take also lead ion. Also, when it is with 2 moles of sodium hydroxide aqueous, you can find lead hydroxide, and this lead hydroxide solid, it is also accompanied by 2 moles of sodium ions. This lead hydroxide, it is a white precipitate. This white precipitate, on the side of zinc 2 plus with 2 sodium hydroxide, you find that with 2 sodium hydroxide, 2 sodium hydroxide, you find that zinc will be hydroxide with 2 sodium ion. It means that here you have a white precipitate. Of zinc hydroxide. As you find 3 ions, no way of distinguish them, but as zinc is the nearest of nanometers, and also lead is below in group 4 of nanometer with silicon, with carbon, with germanium, it can form the compound which are nanometers. Means that hydroxide of zinc and hydroxide of lead are between acid and base. We call amphoteric. Ampho means that between. Means that amphoteric means that it can behave as an acid or it can behave as a base. If it behaves as an acid, it means that it can be neutralized by the base. The reason why this white precipitate will be soluble in excess means that is soluble in excess. This zinc will give zinc complex. Here we have 4 because 2OH will be added, and the 2OH, if they are added, we will find zinc hydroxide. Here there is a 4 and 2 negative. This is a complex of zinc which will take those 2 to form a salt, which is a zincate complex. Means that this is aqueous, means that the precipitate disappears, and on a test tube you can confirm that there is zinc ion. But if also it dissolves, here also by adding other 2OH, this precipitate will be soluble in excess, because continue the reaction to give a complex of plumbate. Plumbate is the complex of zinc with 2 negative. Then this is aqueous because a complex always is soluble. The remaining will be magnesium. For magnesium, it can react with 2 hydroxide to give magnesium hydroxide. But this magnesium hydroxide which is found here, it is a white precipitate. But this white precipitate here is insoluble in excess. insoluble in excess. It means that here, if it is insoluble in excess, soluble in excess, soluble in excess, it means that if you find that the ion are soluble in excess, you can exclude magnesium and you can confirm lead and zinc. To distinguish between them, lead is soluble in excess when there is high alkalinity. High alkalinity. In the following time, the following minutes, we are going to discuss how we have to distinguish zinc and lead. You find that are soluble in excess and another is soluble in excess. Means that zinc cannot react with a base which is not strong, but zinc can react with a base which is not strong. Means that the reagent which you have to add again will be ammonia solution. If ammonia solution is added here, on the side of zinc, there is formation of complex of tetramine zinc, but on the side of lead, there is no observable change. It means that on the side of zinc ion, you add 4 ammonia solution. If 4 ammonia solution are added, ammonia solution, zinc will form a complex of zinc and 4 ammonia ligand. And this is called tetraamine zinc. Tetraamine zinc. It is a complex and it is soluble, means that it is a white precipitate will be soluble in white precipitate of zinc hydroxide 2 will be soluble in excess. Soluble in excess. But on the side of lead, because lead is nearest of nanometer, means that even though it is amphoteric, but it is more acidic compared to zinc. It requires very strong base like sodium hydroxide to be soluble. If we use ammonia solution, because it is weak, it cannot satisfy the solubility of lead. The reason why lead ion occurs with 4 ammonia solution, it gives, first of all, it gives with 2 ammonia solution, it gives lead hydroxide, which is a white precipitate. But this white precipitate, it is insoluble in excess. Insoluble in excess. Insoluble in excess. For this reason, you can here, if you find that solution continue to be soluble in excess, ammonia, with the ammonia solution, you can exclude lead, and you confirm that water contains zinc ion. Thank you very much. We'll continue to discuss about other ions and the other concept of chemistry, either nuclear chemistry, organic chemistry, physical chemistry, volumetric analysis, and I encourage you to click on subscribe, notification sign, and click like to find answers of the question that you need. And if you have children who are students who want to know chemistry, don't forget to click on this channel and click subscribe to see the following question answer for our chemistry lessons. Have a nice day.